let's go.
Thanks, Sam. Appreciate it. Hi, everyone. My name is John Posada, and I am a Partner Solutions Architect at Dataiku. And today, what I want to do is talk to you about Dataiku DSS, which is called Data Science Studio. But before I do that, I just want to give you a little bit of insight in what is Dataiku and how the platform works, and just more information about the product itself before I show you a workshop on actually how to use it itself. So today, we're going to talk about your path to enterprise AI. And so everyone's talking about AI, and everybody claims to see it as being an essential part of the future of the business, but every industry has now identified some clear use cases that should benefit from it. And some of these use cases are like predictive maintenance, demand forecasting, fraud detection, pricing, market targeting, and also personalized recommendation. AI can also be kind of scary sometimes and perceived as a very daunting challenge. For us, for the most part, not as much, because we're more of either the ML engineers, the architects, or the data scientists. But when it comes to the companies that we work for or the companies that we consult for, there's a little bit of a scare there sometimes. And so 75% of companies believe, for the most part, that they will be out of business within 5 years if they fail to leverage AI. Here at Dataiku, we actually believe that AI goes way beyond specific use cases that ultimately a company is as a decision-making engine, and there isn't really a single decision process or product that could be augmented or optimized with AI. So the real potential of AI is really to build the agility to augment and optimize every decision and processes within an organization. So every time it is not about a given set of use cases really, or a given technology stack, but it's more about the full view of how the company operates with respect to building ML processes and understanding AI. So there's a study that shows that companies that think about AI as a strategic scale initiative achieve usually 3 times higher ROI than those that do it with just minor activities. So to build that agility, it is a daunting task, and it could be tackled usually in 3 ways, at least ways that we've identified. The first one is how to fast track to value, and that's around getting value quickly and at scale. So it is how you make sure you're able to deploy not just a few models, but thousands of models and projects quickly and efficiently each year. The second one is durable AI resilience at scale, and that is once you actually know how to impact thousands of activities with AI, the resilience of your organization becomes dependent on the resilience of your AI initiatives. And how do you make sure that AI is an asset your company will be able to rely on for years? And the third one then is a catalyst for company transformation. And that is, now that you have achieved your deployment, your excellence, and your resilience, we look at how to leverage the new normal and working environments to accelerate AI, and how can the new normal be a catalyst for company change. So what that means is, if you manage through these things, then you'll be able to augment and optimize every time. And so we're going to basically go in a few minutes, just each of these individual partitions as I've just shown you now. So the first one is fast track to value. So AI talent is scarce. There's a quote floating around that says 80% of AI PhDs work at Facebook and Google. How much of that is true? That could be a slight exaggeration, but I mean, there is a lot of PhDs that work at both companies. And AI talent is quite scarce, to be honest. So there are usually 3 times more job postings than job searches, and it's really hard to find good data science talent. I know, I tried to hire a few. There's always some concerns there about, is the talent going to fit the persona or not? So unlike talent, technology is usually readily available, and it's all over the place. And there's certainly not a lack of tech today. We do have an open source cloud component technology, but just an example here, with just a credit card, you can have access to huge amounts of computation or power or data. Just another example of the NFL, each of their individual players can create millions of data points for just one single game of play. So however, even though you can execute machine learning, it isn't about access to just tech or just math. It is important, but it's about connecting the data together and also analyzing it, visualizing it, modeling it, and then deploying it. And all those skills sit across usually different teams or functional domains. And so those functional domains could be skills, people, or even tools and technology. And getting the pieces to fit together, which is the second component here, is not an easy task and should never be taken lightly. And some of those examples, we haven't spoken about this, but a good example is, a big technology company on the West Coast in the US, they told us that they were 3 years into integrating their AI platform and actually only managed to connect a few of those pieces together. And there's a recent paper also from Amazon that shows that adding governance and security on top of notebooks can cost usually sometimes around $1 million, give or take. And so with that being said, the third component is 87% of projects fail to achieve impact. So that question is, Does that mean that these projects stay as a proof of concepts or as test projects, or they just never see the light of production, where they can have really a significant impact on the business? And even those that do make it through production, it usually takes several months, meaning by the time you got your models in production, they're most likely going to go obsolete or just use outdated data. Each of these obstacles are challenging in their own right for their own reasons. When you combine all three together, though, it can be extremely overwhelming. So think of the complexity it could add when trying to bring in AI into your organization without resolving any of these issues for fast tracking. So what do? These challenges are at the core of what Dataiku DSS as a platform tries to address. So remember what I said earlier, machine learning projects are not just about ML code. It's also needing your data analysts, your business teams, your data engineers, and whatnot working together. So remove those silos and bring them all as a team. And to learn how to bring all those, the best talent between all those individuals together if you want to be able to deploy 1,000 projects per year or less or more. And if you need to involve everyone in every time, it's not only about AI talent, it's the talent of how everybody that can bring value or benefit from the value of AI together. So for example, your subject matter experts, your DevOps engineers, your ML engineers, your software engineers, or your data scientists, your data analysts. Now, what about all the technology that needs to be put to use for various projects? How do we bring it together into a proper stack? Well, so Dataiku helps with that specifically. It provides a proliferated environment of the best technologies when a ready-to-use stack. So when you deploy Dataiku, you always have an open and fully elastic stack for your data science needs. So you only have to have access to elastic computer storage. If you have access to elastic computer storage from your cloud provider, you can leverage your on-premise technology or connect to your cataloging technology or to your visualization company within the platform itself, because it works as soon as it's been set up with the platform and it works right out of the box. So you don't need to spend years or millions of dollars to get everything running. And so to explain that, as you can see here on that second screen, you can see that we have all those different types of platforms that we can work together with, whether it's on the cloud, whether it's on-prem, whether it's third-party computational products like Spark, Hadoop, Hive, or different sources like platforms like TensorFlow or whatnot. So the last thing I want to show you is do not think about projects as only design, but an integrated part of design impact as well as production. With Dataiku, the full design of data and ML ops is integrated within a single environment so that what you've designed can be orchestrated, deployed, monitored, alerted, and trained on and used with confidence in the production environment that you're using specifically. So the second thing to talk about now is durable AI resilience at scale. So now that you've managed to have your AI deliver value at scale, let's think about the next phase. So building AI resilience. So ask yourself, how do you make sure that you overcome any major risk of AI over the long term? So what are some of the things to look out for? So the first one is AI debt. It builds up. We all know this. What is this sometimes? Well, conceptually, this isn't too different from technical debt, but it can have a much larger impact on an organization with very new AI projects. You're working with specific talent and with specific technologies. These are specific choices that were made at a specific time in the past, but as we know, AI technologies change very, very, very fast. And 5 years ago, everyone was talking about Hadoop, then Spark, and now everyone is talking about like Kubernetes for the most part. And so you find yourself locked into yesterday's technologies, and you're daunted by the task of, when should you switch to the new technology? Should it be today? Should it be tomorrow? And whatnot. And then the second one here is control is lost. So with growth and scale, there's the loss of control, and AI is often done project by project by various teams in an organization, and you're creating unintentional silos along the way. So as a result, you really have a growing lack of awareness that proliferates where people are not clear on what project is being worked on, by whom, where the data is being used, and how much each project costs. So ultimately, shadow AI is what tends to happen, and that creates governance risks that are made that are very concrete by impending regulations. You have users that might want to go ahead and build whatever they want in their own cloud environments and not tell IT about it, but they're using products from the organization. That can be a big control loss right there. So as a result, we're seeing regulation in most regions around the use of AI, and that will require companies to drastically change the way that they let AI grow organically, as well as limit these silos and also have a high level view of what is going on. So the third part for this is AI turns rogue. So which brings us to the point that everyone tends to get scared of. It's like, oh my gosh, machines are going to go and take over the world and destroy us. That's not really the case. But you do have AI goes rogue in the sense of here you are with these models that are being biased against specific genders, race and age for specific organizations. And it's because someone just wasn't paying attention and then realized that what was being built with respect to their models, which can lead to unethical policies, and then also data just going wrong because you're not using it the way you should have if you were a subject matter expert of the business, as an example. So now we're going to go into a little bit more different in the sense of, okay, so first you need to have a full AI agility and to allow you to plug into the best technologies for any given objective at any given time. So you want this because you want to build all of your analytics and business logic on top of your infrastructure, but not be locked into your technology choices. Dataiku is a fully open and elastic stack where you can decouple your projects from the infrastructure and have the flexibility you need. We have some customers that started on SQL, then moved to projects like Hadoop, then again to Spark, and then again to Kubernetes without ever needing to recode anything. And so Dataiku really bears the brunt of this cost and complexity of you switching between technologies and leading you to focus on the business impact, which makes all projects reusable to everyone, everywhere, every time without the additional overhead costs. And in order to maximize control and oversight, your organization just needs centralized AI governance. And so you can view from within Dataiku the projects, the models, the resources that are being used, and how. You can also look at model auditing and documentation of your models as well to help understand what has been deployed. Plus, there's full auditability and transferability of everything from access to data to deployment for each and every project everyone works on. And finally, we can focus on the human-centered responsible approach to AI. And as you see here, that's more so about the objective to know where the data is coming from, how it's being used, and what modelization choices are being made. Also, fundamentally, we want to have transparency into machine learning in itself, not just to provide explainability, but in your features and subpopulation analysis, but to train users on what responsible AI behaviors are, because ultimately it's people that select what data they're going to use, and it's people that decide how that data will be used with the proper trainings and tools that they can become more responsible users of artificial intelligence. So now we look at a catalyst for company transformation. This is the third one of the initial partitions that I showed you before. So as we've seen, the way we work has changed drastically in the last few months, and now most people are working remotely. While there are some benefits, there have also been a few barriers to productivity. So even though you have a laptop and you're able to work from home, the requisite access rights and internet access may seem like enough to work effectively in the new normal. But what is often overlooked is how much AI projects require the accessing of processing of large amounts of data, moving that data from one repository to another, and then using computational resources. And doing all that from your laptop puts significant strain on your VPM system if you're using one, and not to mention all the consequent security issues that can come from that as well. So once you have people working remotely or from home, there's a natural increase of disconnect between business analysts and data scientists. So getting people to bond is not something that can continue to be relied on to happen in the office anymore. And for many global organizations, this is a long-standing challenge. And this is just within the data science teams, not just within the teams, correction, but also through the business teams as well. So if business users are excluded from the process, how can data experts get the domain knowledge they need to prioritize effectively and do projects that will make a tangible impact? So with an increase of virtual meetings and communications, there is the hope that the trivial knowledge of past and future initiatives is maintained in a new way of working. But because of the technological silos between teams, strain on the systems and access to the projects, there's a risk of reduced AI productivity over time. So we talked about AI debt that creeps in with each new project that we deploy, but remember that if you acquire more debt, then you decrease your data productivity. And if because of this, you reduce tribal knowledge as well. So you need to reinvent the wheel for every project naturally that your AI productivity will grind to halt specifically. So we instead need to look at new ways of working as a core element of the new AI effort. How can the new normal be a catalyst for company transformation and accelerate the AI effort? So the first one is by providing unified access to projects and systems without strain on current systems. Dataiku provides this access. It's just basically a browser-based interface, which I'll show you momentarily, that lets you remotely connect to projects, data, and computational capabilities, and everyone can connect to and from home or anywhere to do anything and everything every time as soon as you have an internet connection to the actual platform itself. Now, making sure people work together and maximize output and share knowledge is paramount. So getting people to connect can and should be done directly within the tool and be embedded in the workflow. So in Dataiku, you have collaborative wikis, you have ways to visualize projects, you have data that can be shared across people, and you have change tracking as well for audit trails as well. Then there is the move from tribal knowledge to systematic reuse. The idea here is quite simple. Create a centralized repository for all your AI projects that easily is searchable and reusable. And luckily, the platform provides a repository of your data initiatives aiming at systematic reuse across skills, projects, and time. So about Dataiku, this is just really a one quick slide view of what Dataiku actually focuses on, and that is with Dataiku being the unified platform to deliver impactful AI at enterprise scale. You see here that on the left side, we consider no code, we consider low code, full code, and programmatic control. You are able to empower your users to use well, whatever browser of choice that they prefer, but as well as different IDEs. You can have notebooks being used to go ahead and, for example, build maps that you need to for dashboards if necessary. Go ahead and build your flows, go look at your data sets and investigate them, or write their code, or even work with API programmatically. And as you see here below, we really like to focus on like the catalog and connectivity, data exploration and preparation, auto ML as well as ML, insight sharing, visualization applications, scheduling, orchestration, deployment, and monitoring of your models, or even just your API endpoints if that's the case. And then looking at systematic reuse and collaboration, as well as integration and staging of your flows, whether that's in a dev environment or, for example, in a test or also a prod environment. And then a centralized governance to go ahead and audit everything that has been built and created by who as well. And then horizontal and vertical scalability depending on your computational needs with respect to your project specifically. But with that being said, that is the actual quick presentation I want to show you. So now let's actually get into specifically Dataiku and then show you what it can actually do. So if you can see my screen now, this is actually Dataiku. So for the project I'm about to show you, we're going to focus on previewing the DSS platform and showcase how to build a fully functional ML flow to predict customer churn by integrating diverse data sources, data transformations, exploratory analysis, feature handling, and using native code and visual recipes in a single and governed Dataiku DSS workflow. So you'll see basically how a machine learning model can quickly move from a test environment to a production environment in a few clicks, and how you can set up A/B testing for the models that you've deployed as API endpoints, as well as monitor those models if you need to, look at metrics and checks for data drift if necessary, or model drift, and then figure out ways to score and publish those models via your APIs so you can consume them in your web applications or mobile applications if necessary. So when you first see the platform, so you can see here I've just logged in, and this is the first thing you can see for the first time. I'm sorry if I'm looking to the left, that's where my view is of the actual web platform itself. But you'll see here that on the left side, we have my items, projects, applications, and project folders. This is basically everything that has been built so far in conjunctions with what we call projects. A project specifically is a way to create a pipeline and then have different users and personas work together with you. So I'm going to show you the one that I have here. It's called Advanceml. So if I click on it for the first time, when you log into a project and you create one, you'll see here that you have the title for your project, you have a brief description, and then you can see here that you have multiple users. In this case, I actually have 4. So you'll see here that since we have 4 users, we actually have roles-based access control, RBAC, so you can assign permissions to individual users for projects. Users can work collaboratively together in one project, so they can be either a data analyst, a data scientist, a data engineer, a system admin, or a software developer. They can all work together in the exact same project in conjunction with each other collaboratively, and that's because it is a web-based platform, and so we don't have limitations in that capacity. And we do also enable specific types of permissions for each of these users for restrictions if necessary. But when you log into your project, you'll see here that you also have some tags. So projects can be tagged so you can search for them later in what we call our catalog feature, which I'll show you later on as well to give you an idea of how that works. But once you've logged into your project, you see here there's a window for automation. I'm going to show you that later, but you have a way to automate your projects based on triggers, whether that's specific timeframes or maybe a change in your data sets, or maybe based on metrics and checks. We'll see that later. It's going to be called scenarios. And then I'm going to skip this here because we're going to look at that momentarily. But you'll see here we have a window that we could provide you with a brief description really of your project. For this project specifically, we're just trying to predict churn. I'm not going to focus too much on the project itself and the fact that we're trying to determine the actual accurate metric, but show you more so how you can go ahead and build a project in the platform and then take advantage of the different resources and features that the platform does offer. So you see here for this window description, you're just writing it in markup code. On the right side, we have a to-do list where you can go ahead and create tasks specifically for any single individual on the team. You can basically write that task out and then just tag them name. So if they're a part of the platform, they have a username, they'll be informed that they've been tagged in a project, and they can go ahead and access that project and find out what the task is. On the right side, you see here we have a timeline. So this timeline really is just recording what we would call a commit. It's using version control in the back end. So really what we're doing is that we're recording every change that's made at a recipe level. I will explain to you what a recipe is momentarily, but this means that when you're building a project and you're building little components and pieces to build your entire pipeline or your flow, we like to call it a flow as our terminology here, which is the same as a pipeline. You have the nodes, which are little pieces that connect the flow together, and which we call recipes, and I'll show you why we do that. But that will basically help you in understanding, okay, if John has made a change, John made a change in this specific recipe, and you'll see here, it tells you what I changed exactly and specifically. And then you can see down here that we have everybody else that's been a part of the changes that have been made in this project specifically. You can also go to our settings and just click on version control, and we will show you every single change that's been made since the project has first been created. And you can just go ahead and if you click on it, you can compare one commit to another one. Any change that's been made in the project is a commit. Then you can go back and revert a commit if you need to. You can create branches as well if you need to in version control for these projects, and then determine how you want to merge them together later on based on the changes that have been made. So I'm going to go back to the flow. So in the project homepage, after I just showed you the timeline, I'm going to click on the button called Go to Flow. So when you click on the Go to Flow, it's going to show you a view as you see here. It'll mostly just be white for the first time, but this view is a representation of a flow and what's going on in that flow. As you see here, we have these little recipes or tools. We call them recipes because what we've done is we've attached colors to each of them. As you see here, the recipes that show up in blue represent data sources. That means that we can connect to over 40 different data sources using the JDBC connection. For most of those that are databases, here I can give you an example. You can see here we can connect to a network, we can connect to Hadoop, we can connect to Hive, we can connect to multiple SQL databases as well, some of those cloud databases that exist as well. We can connect to some of the cloud storage providers as well. We can connect to NoSQL. And then if a data source does not exist, you can go ahead and create what we call plugins, which will allow you to basically just create a recipe as a third-party product that would allow you to go ahead and just create an integration as a connector to connect basically to whatever data source you need. And you can use Python or R in the backend for that environment if necessary to make that connection as well. So like I was saying before, the blue recipes are for data sources. The orange ones are for code recipes. The yellow ones are what we call visual recipes. So if you haven't noticed, the reason we call them this way is because we look at the different personas that have to work together. So in this entire flow, you can have a persona of a data engineer, a couple of data analysts, a few data scientists working together. So these visual color recipes make it easier for them to understand, okay, I'm going to feel more comfortable in using these types of recipes. That doesn't mean I can't use one or the other. I can use all of them, but some of these recipes are more tailored towards me. So the yellow ones are more for individuals that like to use drag and drop features, don't want to programmatically code anything. That's fine. No code, that's your path right there. But if you like to code, then the orange recipes are there for you to go ahead, bring your code environments with respect, for example, Jupyter notebooks, or even your IDEs, connect them to the platform and use them. And I'm going to show you examples of all that and how we can do that. So normally this flow wouldn't have what you see these boxes here. They're called flow zones. We call that because these are specific zones in the flow that have some form of designation in the project. It's not tailored to anything besides just being really a tag. So here I have data ingestion, I have data transformation. I remember reading something yesterday about data prep, and I really like data transformation better than data prep, so I wanted to make sure I changed that. Thank you, Jennifer, for that one as well. And so you see here we have another flow zone where we're training models, we're testing trained models, and then we're looking at metrics. And then I've got two more here that I'll show you momentarily towards the end of the workshop, exactly what these pipelines are doing specifically. But in the first one, and then data ingestion, you can see here I click on my data source, which is connected to Athena in this example. And you see here that I can see, for example, a quick sample view of the entire data set that I'm going to ingest. So we see here when you have 3,300 rows, that's okay. That's not the entire data set. It's just because what we do is when you're going to investigate your data, you don't always want to go too much into the entire view of the data set, maybe just a sample size to get an understanding of what's going on, a quick overview, and then investigate further when it's time to run some computations on the data, what exactly you want to do. But you see here, we can see all the column names. In gray, we'll see what the original data type was of the data source you were using to ingest. And then in blue, it's just a data type that we assume for the platform based on the data set that we're actually taking a snapshot view of real quickly. We also have charts where you can go ahead and just build the charts that you need specifically with respect to your data sets. In the example that you see here, I just quickly made a pie chart to show that I can look at individual states and the count of records that they have for every single individual that's providing me that I'm having information for this company specifically. I can also go ahead and click statistics and just look at building specific statistical cards if I need to, that we provide as a default. And if you want to, you can always go ahead, grab one of these and just deploy them. If you click here, there's an option that says publish, and that will basically publish any of these charts to your own dashboard interface that we do provide with the product, so you can go ahead and get more insight with respect to your data sets and maybe provide this to someone depending on the impact that you want to see or the insights you're curious about with respect to your data sets specifically. But if we go back to the flow, that was just showing you what a data set and a data source looks like specifically. When it's time to ingest that in another recipe, what you do is just click on the original recipe, click on the arrow here, which opens a panel, and then it will give you options to visual recipes, code recipes, plugins as well. As I mentioned, plugins are just third-party recipes that are created by someone. But what you do is just click on the one you want. So I have here a Python one. If I click on the Python recipe, it'll just take me to the view for Python. In this case, this is just a basic change that I'm just making just to show you an example of how you can use a Python recipe. A recipe in itself, you can either write it as regular code, or you can go ahead and just edit in a Jupyter notebook. So if you want, you can go ahead and view a Jupyter notebook that will just reflect specifically that code and then run the code if you want to extend Jupyter. You can see here with kernels, you're also able to go ahead and create your own environments. And so for environments, that's handled differently. If we go to the administration, we can go ahead and actually either import the environments that we need. So we can import, like, for example, Python 2.7 or 3.x, whichever version you need, import into the environment to use with each of these individual recipes or multiple recipes if you want to go ahead and run your code. So if you already have your Jupyter notebooks that you've written out and you're using them in your original platform, you can go ahead and just copy and paste those Jupyter notebooks into the actual flow, depending on what you need to do with them, and then just upload them to a recipe and start working with them if necessary, and just have your flow run with your Python recipe as an actual Jupyter notebook. And at the same time, if you want to just create your own Python environment, you could go ahead. To show you an example of an environment, you can just go ahead and see that we're going to do the installation of these libraries using pip for the most part. So you just go ahead and do pip install all those libraries that you need to actually use for your environment, specifically if you want to just plug and play the code that you've already written, or if you want to write code as well. So we go back to the flow. So that was just looking at how to mess with Python recipes specifically. Again, there is a different set of levels of recipes to use. We have SQL, we have Impala, Pig, Hive. You can also use Spark for Scala, SQL, PySpark, or Spark R as well. And we also have recipes for streaming data that you would use, like, for example, with Spark, with Python as well, or Kafka if you need to as well. So just be mindful of that there's many different ways of coming in and bringing code. This is not just for coders, it's really for coders, non-coders, and really those different personas that can work in conjunction with each other, so we can break all those silos so they can work together as one unified team, really. And the reason I'm telling you that is because I also want to show you how that helps you build that flow that you want, that end-to-end flow specifically with these different team members as well. So I just showed you a code recipe. When you're building these recipes where it says outputs, in any recipe that you're looking at, it allows you to actually decide how you want to output the data set that's going to be created specifically with this recipe. In this case, I'm just going to go ahead and save it in an S3 bucket. And so if I go back to my flow, you'll see that that data set now belongs in an S3 bucket specifically. If you haven't noticed, with a flow, you can have structured and unstructured data. There's really no constraint on either side. And that's important for you to know, because it's going to come back to a moment of how do you handle computation. So I just showed you how we ingest data. Now I went ahead and created a flow zone where I'm going to go ahead and transform my data. So the data is going to come from the S3 bucket is now going to be fed into a visual recipe. Specifically, this is what we call a prepare recipe. And this is a recipe that is visual, again, drag and drop, but it does allow you to apply different types of transformations. In this case here, you'll see we have an option called the script. Let me turn off that feature real quick. So you'll see here we have an option called script and initial steps. So in this visual recipe specifically, you're able to create as many steps as you want that will run in a script that will allow you to go ahead and transform your data sets specifically in the manner that you desire. We do offer, with respect to steps, over 90 different libraries that you can go ahead and use to transform your data as you see fit. And if you haven't noticed, it still shows a sample set, and that's okay. That doesn't imply that whatever we're doing these transformations, it's only going to be at a sample set level. It's going to be at the entire data set level. We're just showing you a quick snapshot view of whatever changes you make at a sample level, so you can know the form of transformation that will be applied to your data set specifically. So in this case, you select basically whatever processor library you would want to use, and then the functions that you have available. And you see here we have brief descriptions of each of them. What will happen is if you click on any of these that have already been created, you can see, for example, in this case, we're going to rename a column. We're going to replace some values, some labels, basically from the churn column, basically the feature that we're trying to predict at some point throughout this flow. And then you can also see that we're going to look at replacing a couple other values and other specific types of features. I didn't make this as extensive, more so because I want to give you the idea of just the simplicity behind just picking a step and then using that step to transform your data as you see fit. But if you want to apply Python as well, you can inside of this actual recipe. Just type in Python as an example, and you can go ahead and apply a function that will basically be applied at a vector level specifically for the features that you're going to go ahead and transform or that you want to transform. And now the power behind this is that not only can you do that transformation, you can also handle the actual computation behind this transformation. So on the bottom left, there's an option that says local stream. If you click on that, the local stream will actually show you how to select what we call recipe engines. And so that basically means that you can assign different types of computational engines to actually handle the computation for your data sets. So in this case, I showed you a snapshot view of the sample size data. That's really just a snapshot that's being saved in cache. We're not looking at the entire data set. Remember, we're just looking at a sample size set of it in cache, and we're storing it in cache. And then what's going to happen is that, for example, if the input that was fed into this specific visual recipe came from a SQL database, then you have the option to go ahead and use in database as your actual computational engine to run whatever computational steps you've created inside of this actual prepare recipe specifically. Or if you want to send it off to Spark, you can do that. You can also send it off to Spark and Kubernetes. Really, the option is yours based on which engine you've actually assigned or you have set up for Dataiku to actually go ahead and orchestrate and manage for you within the actual platform for the assigning of your projects. Your engines are automatically chosen by default based on the connections that you have set up and the connections that you have allowed your users to use when they're actually running these specific types of recipes inside of a project, inside of your flow. Just to give you all that, it's a lot of information, but give it all to you just because I know it'll come up as a question. But just be mindful of that you can handle the computation as well externally if necessary. You don't have to do it internally with the product. So once you click on run, it'll just go ahead and run this entire process. And so what happens is all these steps now will be ran against the entire data set and no longer just a sample size. And in the end, what that happens is that just creates you another data set. And then it gets sent off to another visual recipe where in this recipe, what we're really just doing for the most part is just splitting your data set. So let me zoom in to show you a little bit better what this looks like. So you see here, we're splitting the data set into a train and test data set. If you click on this visual recipe, it just gives you certain rules that you can create to satisfy how you want to make that split. There are different ways of filtering this. And so again, this is going back to, you can code it. You don't have to code it. If you want to code it, you could have just used a code recipe instead. If you want to use the visual recipe, by all means, it's right there for you. Remember, that's bringing back those different personas to work together in the same flow and let them decide as a group how they want to manage building the flow for the ML project they're about to build. So if you go back to your flow, you can see here that now I've split my data set into train and test, and I've left the data transformation flow. And now I'm going to the train model flow and the test train. So before I get to test train, I need to go to the train model. So you'll see here that this S3 bucket has been provided now for 3 new recipes. So if I click on the data set again, I click on the panel, remember you can choose which recipes you want from the panel view. In this case, I have Python, R, and AutoML. So if I click on the Python one, you can see now if I click on my edit in notebook, that's override notebook content. You'll see here that I can see that basically all the code that I saw in that script perspective is now being written to just run in my Jupyter notebook. We don't have limitations for the most part on any of the libraries that you want to use. It's a matter of just installing them yourself and going at it with them. But you can see here that I'm just creating my own predictive model in Python. Specifically, I'm creating a random forest classifier because I'm going to go ahead and create a predictive model and then store it in what we will call a managed folder. And I'll show you what that looks like. It's one of the best ways in the platform to handle unstructured data specifically. But you can see here the Jupyter Notebook has its own kernel that's been assigned to it. So basically, I can go ahead and just run the Jupyter Notebook inside of the platform itself. For those of you who instead might have more of a preference, for example, to just using code, in your current IDEs and you don't want to write your code specific in the platform because you don't want to leave the platform, I mean your IDE specifically, then that's fine. So you can see here, this recipe is called compute_prn. If I go to my IDE, in this case, I'm just using code as you see here. I can go ahead and just write the recipe that I want in this capacity. I've connected my IDE to the platform using API keys. So I'm basically communicating with the platform, and basically all of the recipes that you see stored in the platform itself are available locally to me to go ahead and modify the code the way I want. So in this case, I can say, this is not the right one, but let's go into the Python one. So we go to this one here, and we just say, John is super happy today, and I actually am. So we go ahead, we type that out, we save it, then we just go back, and then we just go ahead and refresh the actual recipe itself, and you should see, there you go, it just showed up inside of the recipe that's running in your flow. So again, the preference is yours. You can either write the code in the recipe or just have it written in your IDE, and that will automatically go back and link specifically to your flow based on the recipe you have available. And the same is applicable to R as well. You can go ahead and open that in Jupyter Notebook if you want to, override the notebook. And then you'll see that you can go ahead and just write your R code as well. And you can also set up your environments for R code in the same capacity as you did specifically for Python as well. And then going back to the flow, there's something here called AutoML. So you haven't seen this yet. So if I click on a recipe, there's an option that says lab. If you click on lab, we provide you with either going with the option of visual analysis or building Jupyter notebooks with predefined templates. If you choose visual analysis, we call that our AutoML recipe. You can choose supervised learning, unsupervised learning models, or deep learning. For the supervised and unsupervised, we're mostly using scikit-learn libraries. For the deep learning, we're using Keras and TensorFlow on the back end. So if you pick, for example, supervised, in this case, we're going to predict churn. So we already know the target variable that we're going to predict. So if you go ahead and click on churn, you can then pick between, in the AutoML section, which of these models you want to pick, and then basically what parameters you want to change with respect to your model. So quick prototypes, interpretable models, or high performance. Go ahead and click the one that you want. If you do, for example, quick prototype or interpretable or high performance, there's an option that says in memory. That's because you're actually able to also go ahead and bring in, for example, MLlib libraries instead. If you have Spark set up to use in the environment, you can take advantage of that. If you have H2O or Vertica as well, you can go ahead and take advantage of using the models that come from those platforms as well within the product to use instead of an AutoML recipe. And then you have expert mode. If you don't say, hey, I don't need to use AutoML, I can do it myself. Power to you. I'd love to see that. So make it happen, and then just go ahead, choose your option, click create. And what that will do is it will then take you to a visual analysis view for the most part of your actual data set, where you're going to go ahead and first design and train your model. So before you see any of this, it'll just show up blank, and it's going to ask you, do you want to train your data? You're going to say no, because you're going to always click on design first and determine what you need to change first for your AutoML. Is there anything that you know as a user that you want to add? This is something a data analyst can do, or a data scientist fairly easily. So for example, you can look at the target variable, what type of classification is for prediction on these classification. Is it two-class classification, multi-class regression? Make sure you chose the right target variable. If you didn't, what metrics do you want to use specifically? How do you want to handle feature handling? You can go ahead and look at all your features. Look at, for example, even you handle some imputation, go for it. So feature generation, feature reduction. We offer you a set of default algorithms by default. It's like over 10 of them by default that we do offer. You can add more by creating more models in Python if you want to. Again, this is just the AutoML. If you prefer the code recipe, have at it to build your models. If not, you can do it basically from the AutoML for those users who might not have, for example, the skills to go ahead and build the predictive model just yet. They might be a citizen data scientist, maybe, potentially, or a data analyst. They're more than welcome to. But each one of these options will provide you with parameters you can go ahead and change. You can turn off, you can turn them on as well if you need to. And then the parameters are based on, like I showed you just before, those three sections where you can choose between interpretable, medium level, or advanced. Will allow you to go ahead and change the different types of inputs that you would want. And then you can see that for runtime settings. And one thing I get to show you for your code environments as well, for the code recipes, when you're running all of these recipes, specifically the code ones and the AutoML, you can obviously pick your own environment that you want in Python, or specifically for AutoML, or R for just the regular recipes. But you can also go ahead and assign the computation of these models to a container that would run in Kubernetes. So in this case, if you have some of these models that you've built, say, for example, in your own code recipes that need to take advantage of GPU processing, then that is something that you can have set up in your model, in your code, so that when you then have a Kubernetes cluster attached to the actual platform itself, you can go ahead and just send off that job to go actually run inside of a Kubernetes cluster, where it will go ahead and run your code and take advantage of whatever processing specs you've set up to be consumed with inside your actual code inside of the actual Kubernetes cluster specifically. So that's just to let you know there's no restriction in that capacity at all. Again, if you're full code, bring it. We're all here for you. If not, no code as well. It's up to you. We try to keep that collaboration in the same place. So once you decide on the model you want, you just go ahead and click on train. And so what's going to happen is when you go to results, we will show you then all the models and then their metrics that are attached to each of them. We'll give you a metric and a score. And then depending on how many times you've done a train, you'll see here you have different sessions. This is for us to basically understand, okay, great. This is the metric score that we have assigned, and this is the best score. So if you want to use that model specifically with the best score, just click on the model, and we'll show you some more information about interpretation, performance, and model information, like variable importance and whatnot with regards to the models you've used. And at that point, if you feel comfortable, you can either deploy it to Jupyter notebooks you can use internally yourself, download as PMML, fat jar, thin jar if you need to, or you can go ahead and just click on deploy, which will then deploy for use with inside the flow. Deploy here means just using it within the flow that you've already built. So what that means is that now you can go ahead and use this, for example, AutoML recipe that you've just built here as a deployed model, where you can go ahead and attach it to a scored recipe, and then attach a data set to go ahead and run against specifically the train model that you just made. As you see here from the perspective of Python and R, we created models and stored them in what we call managed folder. A managed folder is a great way to manage unstructured data, which can be connected to remote products as well, like for example, remote cloud environments, where you can go ahead and store your models that have been created in here if you need to, and then go ahead and consume them later on. For example, in another code recipe, like you see here, I have an R recipe because I've gone from the train models flow to the test train. And inside of this test train flow zone, you can see that I now have it where I'm consuming the models that are creating these managed folders for both R and Python. And I'm consuming the actual AutoML recipe or a scored recipe to go ahead and produce for me my scored results. So if you click on any of these data sets, you'll see here then, if you scroll all the way to the end, that will show you basically the outputs of the models that you had. In this case, the true and false, basically the probability of whether or not this customer will churn. 80% says that it's false, and then 17% says that it's true. In this case, you predicted false correctly, as you see here. But that's just to give you an idea of how to take advantage of using your own predictive models that you've built or using what we provide out the box. And then you'll see here in this zone, we have metrics where these data sets are recreated. If you click on them, you'll see here that we basically just have the exact same output that you saw before, false and true. But now we're going to use that because we're going to go ahead and feed them, all three of them, into a Python recipe to go ahead and run and create a metric. In this case, just an AUC metric is what we're going to use with respect to those three specific models that we just created specifically. So if I go back to flow, you'll see here that this new data set was created. We'll now have just basically the metric that I have for those models. What's important about this is that you can go ahead and create, if you're inside of a data set, any data set in general, see where it says status on the top, we have an option where you can go ahead and create metrics. And so you see here, I've created metrics for like the minimum value of AUC between these three models and whether or not I have a warning because maybe that metric fell under a certain limit or threshold that I was expecting. So if you go to edit, you can go ahead and just create your own statistical metric based on what we offer here as the different options, or you can create your own using Python or SQL if you need to. And then that metric, once it's been created, if you click on checks, you can go ahead and create rules to determine for you, for example, like what is the soft min, max, what is the minimum or the maximum, what rules you want to set in place to check against these specific metrics that you've created. And that's important to know because that's how you can create what we then call scenarios. And so scenarios is really a way to automate this entire flow for yourself. So you see here, I have one that says train the model. So if I click on it, I can see that in here, I have a trigger that can be either time-based, data set change, or SQL-based. And you see if I click on the time-based, it tells you I want to run as frequently as I need to, maybe every minute, every hour, every day, or maybe on a specific day, at a specific time. Or maybe I just want to run it because some trigger, maybe a data set changed specific in some way. You can do that. And then what you do is you go to steps and we'll show you all the different steps. So for example, in this case, I want to build the churn data set that I created in the beginning. Great, add that data set to build. Then next I want to go ahead and build the prep data that I need from the flow zone that I just showed you. Well, prep transfer, data transformation correction. So you can see here, these are two data sets that will be created. And then lastly, I want to go ahead and just train my model. So I'm basically training my model once every day or as often as I need to. And so that will basically go ahead and train that model that you saw here that was just created for consumption and use if necessary. But you can also have it where you can create metrics where, for example, model drift or data drift. I have a new metric I created called retrain model. If I go into steps, it's going to basically go ahead and build the metrics that I showed you at the end, but it could be at any given point in your flow where you're going to go ahead and rebuild your metrics. So outline the metrics you want to be built. For the churn one, I built there more of a metric that looks at the number of columns and the number of rows, more like a data drift in that perspective. I'm going to say go ahead and compute the metrics, attach those data sets once they're built. Then go ahead and run the checks that I created that I just showed you about, like, for example, a soft min, a soft max. And if I say, for example, in the last step that, the process was successful, basically that, all my requirements were met, then great. Either I run the retraining or I don't, depending on whether or not a success means for me that those checks have failed or they've succeeded. Just depends on how you want it. But that's something you can build automatically as an automation process, as a scenario. You don't have to code that. We automatically just provide that for you as a feature within the platform. Now, the reason I want to show you all this is because to tie this all together, I've just showed you how to ingest your data, transform it, train models, test your train models, build metrics, and run checks. But what's important is, can I go ahead and grab these models and build an API endpoint from them? And the answer to that is yes. When you have an AutoML recipe, you click on the panel on the right, there's an option that says create API. You can go ahead and create what we call an API service. You provide a name for what you want, and it will take you to a section called API Designer. In this case, for AutoML, you'll see here that I have the model that I saw in that actual flow. I can go ahead and run some test queries against it and go and get back a response for the prediction that I would want specifically for the AutoML recipe. Or maybe instead I want to create my own recipe in like Python or R, maybe using like a custom prediction classifier or regression model, or maybe I just want to go ahead and build a function. You can do that as well. And in this example, I actually went ahead and built a Python recipe. Now this recipe is, I created an endpoint in Python where in this specific endpoint that I've written, I'm actually having the pre-processing happen when I'm collecting new data. So I could have had this API endpoint where we communicate, for example, if you're anyone's website, you provide the input of the data, but that data is still raw and you need to have it go through some form of pre-processing. Well, what's going to happen is I'm ingesting specifically that feature that was provided as an input, and I'm going to provide it where I'm going to communicate with the REST API of the platform itself, store it as a CSV file, and then have it where it'll go through a scenario that's actually set up in the flow. And as you see here, I'll show you the scenario. Is basically these two little pipelines that I built here on the side, where I'm also having data pre-processing happen. So the same pre-processing we saw here below, it's going to happen now here, but for that specific API endpoint, that would be, for example, in a production environment. In this case, you wouldn't have it this way. That production pipeline will be in its own separate flow, but I'm showing you as a full view of the power behind being able to build these type of pipelines and how to take advantage of them and how to build scenarios around them specifically. So in this scenario, you can just see that I can ingest specifically that input that was provided. And just to show you that again, so you see here for the Python one in code that I've written here, I'm going to activate a scenario that already exists. So you see this is the scenario. I'm using our API key internally, and then I'm going to have that scenario run through my data preprocessing and then come back and get the output that I need specifically from that data set, from that data input that was provided through that entire flow. And so this is just an example to show you what a query will look like. So basically all these inputs would somehow be provided by a user or by us specifically in a platform that would communicate with this API endpoint. And at this point, if you're ready to use it, just click on push to API deployer, and then that would really go, and let me show you this last part, to our platform. That's called API deployer. That will let you basically go ahead and grab your API endpoint that would show up as a service with a specific version, and then have it where if you click on deploy for any of your services, you can go ahead and deploy it in a dev, test, or production environment, which can either be a Linux box or Kubernetes cluster that will run these endpoints for you as API endpoints specifically for consumption in some way or form. So you see, I can just go ahead and determine, which of the infrastructures I want to use specifically, what version of this model, this API service specific I'm using. And if you go backwards, it'll basically create this view as you see here, where I will have my API endpoint, the sample code where I can communicate by providing any form of input, run some tests against it with some test queries, as you see here. I can just go ahead and run specifically against the actual endpoint. And if everything looks good, I want to use it, I can just provide that to any given user. So here's where you have a persona of a data engineer, or maybe a software engineer that would say, hey, we created that API endpoint for you in the API deployer. We're going to provide this to you now. Now you can go ahead and use this in the platform that you need. so that you can start providing inputs for you to score these specific types of, for you to score against the model that this API endpoint represents. And you see here, we can run queries against it. We can see how, what number of queries per second we're receiving, what's the processing time for each of those queries. If you go into the settings, you can do A/B testing by just going to general settings and saying, hey, if I have multiple versions, which I do, then I want to create a strategy where I can do some A/B testing between the different versions, and then have it where I have a random probability assigned when there's incoming requests coming in for these API endpoints specifically to help me assign my endpoints. But that is mostly everything that I wanted to show you with regards to a flow and an end-to-end flow that really encompasses different types of personas working together and having a pipeline that exists to train your models, to test them, to determine your metrics, and then go ahead and create a production pipeline. Again, the production pipeline will be its own separate flow. I'm just showing you it this way so you have a better understanding of the whole picture as a whole holistic view of how that process would go ahead and play out. And the pipeline, you can see I'm just doing the same thing. I'm running these different models and I'm producing my outputs that I would want for my scored responses. And when I showed you scenarios as well before, you could have done those scenarios as well with respect to model drift, depending on how you would just build the metrics for the model drift that can be built in a scenario as well and give you the output that you desire. But besides that, I am actually done and I'm open for Q&A. I'll stop sharing screen. Okay, so there's some questions that have come in. Let me see if I can get them. Does not show up. So is Dataiku competing with Kubeflow and MLflow? So I wouldn't say specifically compete with them. I mean, we are two different types of platforms. We do compete with them in a certain capacity, but it depends on what you're really looking for. With Kubeflow and MLflow, you're fully focused on the whole ML ops view. Sometimes you won't even consider the personas that need to work together, but it depends really on the company's policy and your change management process and your culture on how you manage the whole holistic view of your ML ops opportunity in that case. But with the platform that we have specifically, we try to focus on all the different areas like ETL. We try to focus on building your predictive models, deploying your predictive models. So there's a lot of different perspectives there. We do work as an orchestrator. So in some levels we could be, but I wouldn't say that we are like 100%. I wouldn't identify us, at least not in that capacity specifically, because we do work in conjunction with Kubernetes specifically to go ahead and manage the computation and also how you can deploy your predictive models as API endpoints with your replicas. And you can actually even use Kubeflow within Kubernetes, just depending on how you use Kubeflow for your deployment as well. That's something you can just build in your images, depending on how you deploy your models, for example, into your API endpoint that rests inside of Kubernetes. The second question is, how does Dataiku promote reuse? Doesn't each pipeline become a separate entity? Excellent. So yes or no. So one thing I get to show you, and I would love to show you this now, when you have a project that's been created, if you go back to the Rubik's Cube, you see here where it says catalog, every single item, every single project that has been created is automatically stored and managed because we're using version control on the back end. So if you've seen someone that's built a project and you realize, based on the description of that project, or even go investigate that project, that you can use that project, all you need to do is just go ahead and copy that project. So basically you would click on the project itself, click on actions, and you can go ahead and just duplicate the project or even export it. If you have your own environment of DSS, you can go ahead and rebuild that project and use it again for yourself. So with reusability, there is definitely no issues there. You can do that with respect to, like I just showed you, a project or even an individual data set. Any data set's been created or that's been used within the platform. As a matter of fact, if you click a data set, it'll tell you exactly who created it, by when, how many columns it has, what was the initial data set that was created from this data set. Or for example, what was the data set previously existing before this one was created, and then all the data sets that were created after this initial data set specifically. Let's see what the other questions were. Give me 1 second. Let me stop sharing again. Here you go, chat. Okay. Can you define the pipeline as code? Yes, you can. So you can define the pipeline as code. So with our REST API that we provide publicly, you can just go ahead and programmatically build those pipelines if you want, just communicating with the REST API and assigning the connections, the data sets you want to use, and also the recipes that you want to use throughout that entire process. Can you define the metrics as code? Yes, you can. So I just think I showed you where you can just go ahead and create the metric as a code if you want to instead. within a data set specifically, or you can just use a code recipe and just create your metric in that capacity if you want to. Are they version controlled? Excellent question. So the recipes at the high level view are version controlled, and they're technically version controlled because they're JSON objects. So every single recipe is a JSON object that's reflective of the flow. So we record that inside of version control. Specifically for some of the code recipes, we're actually having some new features that we're working on that will do it even beyond the level of the recipe. I won't share too much because that's not publicly mentioned, but there's some new things that are coming that would answer that question that you just asked. So that was the chat, but I can't see the Q&A. Can someone tell me what the Q&A questions look like? Doesn't show up. Oh, here it is. Attendees. No, it still doesn't show up.
Hey, John, can you hear me?
Yes, I can.
All right, so the first question is, how does Dataiku handle data transfers? How does the data flow between the different parts of the pipelines?
Excellent. So when it depends on the recipes you're using. So for the most part, when you're moving data between the pipelines, so I'll show you that again by sharing my screen. But if we go back to the flow and we go back to a flow specifically, you see here that every single recipe that's connected, especially one that has a data set, what we're doing is we're just saying the catch view of the random of a random sample set of the data. That's all. We're not looking at the entire data set. The entire data set is not being transferred through the flow, only a sample set. So if I click on, for example, any of these data sets, you'll see here that we always see just a sample set, a snapshot view basically of the data that we're actually going to manipulate. Because what happens is we don't need to see the entire data set. We don't need to see a gigabyte of data as an individual data set as a recipe every single time in the flow. Instead, a sample size is more than enough. So we'll save that in cache inside of the platform itself. And then when it's time, depending on where you want to store that data, we'll just make the transfer between those two different data sources, depending on how you want to transfer that. If you're just doing, for example, an ETL transfer, then when you click on a data set and you click on the panel, there's an option here that says sync, which will allow you to basically transfer your data between those different environments, depending on how much of the data you want to transfer specifically. Second question, I think.
Yep. So apologies, I was muted for the first one, but how would you position Dataiku in the overall ML tools landscape? Is it an end-to-end platform? Is it an orchestrator? You kind of spoke to the orchestrator piece, but do you consider it end-to-end?
So I would say it's both. And when I say both, so orchestrating in the sense that you can go ahead and orchestrate out the computation of some of the tasks that you want to handle. You can orchestrate the creation of the clusters to handle those computations. So here's a perfect example. With, for example, AWS, Azure, GCP, you can go ahead and use the Kubernetes services from each of those environments, set them up as configurations at Dataiku, and they basically have Dataiku go ahead and build the clusters that you need for Kubernetes inside of those services to go ahead and either handle one, the computation, or two, the creation of your API endpoints if necessary for consumption and use of the flow. When I say end-to-end, I mean more from the perspective of, you need to handle data governance for a certain extent. For example, how to handle the connectivity to those different data sources, bring them all together to one resources, but then go ahead and grab those different data sources and transform them, and then go ahead and build your predictive models and then go ahead and deploy them. You can do all that in the platform. There's no limitation in that capacity. So we say end-to-end more so because we're also considering the personas, which are very important for an end-to-end platform. You can't say you have an end-to-end, in my opinion, of course, that you have an end-to-end platform, but you only have 2 or 3 users, because if those users are, for example, just a data scientist, well, what happened to the subject matter experts if they're not the data scientists? What happened to the DevOps team? What happened to the ML architect or your software engineers who all still need to work together with you to bring in that flow that's been built in a production environment or that will be needed in a production environment to actually place it in there. So in that case, you need to consider all those different components. But that's, again, my opinion solely. So please don't take that the wrong way.
All right, let's try and grab one more. What's the backend for Spark? Does it work on GPUs for faster training pipelines, e.g. Rapids?
Let me double check on Rapids. Who asked that question specifically? If you can send me a note, I can send you a reply back. Let me double check on Rapids for you.
That is Mayank Bhaskar.
Mayank Bhaskar, okay. Mayank, I will come back to you.
And so let's grab one more. How does the workflow support different types of team members, data analysts, business leaders, data scientists, et cetera?
Excellent. So specifically, when it comes to different personas, everybody has access to the flow as long as you give them permission rights. But what I was mentioning before is that each of these recipes, they tend to have a color position placed on them, and that's technically making it more comfortable for those different personas. For the most part, if you have your data engineers, the data engineers mostly handle, for example, the blue color recipes or maybe the orange recipes, depending on what they need to do. You have data analysts that might just work on the data ingestion, data transformation. And then when it comes to the training model perspective, they'll say, hey, to my data scientists, we've already manipulated, we've already transformed the data in the manner that you want. From this point, the flow is set up where now you can go ahead and apply whatever you need to programmatically if you want to, or non-programmatically to build the predictive models that you would want. So everyone knows what's going on. And the best part is every single recipe, if you click on the open panel, there's a button called details. You can go ahead and provide information here by editing it so that you can actually explain to your team members what each of these recipes are doing, whether you're an analyst, data engineer, or data scientist, and they have a great idea of what's going on in the flow specifically.
Great. We've got a couple more questions, so let's try to sneak these in. With this system, how do you handle reproducibility?
So when you say reproducibility, what are you trying to reproduce specifically? Is it more like the flows? Is it specific different types of items? Because everything that exists inside of the platform, if you go into the catalog, you're more than able to reproduce it and then reuse it if necessary. So you have a track of every single item that's been created in the platform for reuse. All you need to do is go ahead and select that specific item that you want to investigate, and then go ahead and you share it with yourself or just recreate it if you need to. So that's more open-ended kind of question, but we offer reproducibility on everything that you create in the platform.
All right, Gavin, if you want to elaborate, let us know in the chat. But for now, we'll jump to the next question, which is Ben Caldwell. Does a flow store the version of data used for training, for example, for model in production? Do we know what raw data was used, which version of transformation or labeling code was used, et cetera?
So that one depends. So if you're using the AutoML recipes, we don't versionize the data, we do versionize the models. So if you click on a flow and you're looking at, for example, an AutoML recipe specifically, if you click on the model that's been deployed to the flow, you'll see that we have every single version saved specifically of that data set. Now, mindful, whenever you retrain, the first question that's asked every time you retrain a model in the AutoML recipe is, do you want to reset the schema and the data that was previously used when you were training this model? For example, maybe since it is a random set, it might have a specific seed. In that capacity, then each of those data sets are stored individually for each version trained model specifically. But more so, do we versionize the data? No, we don't. I know that's a feature that we're actually working on as well, but not at the moment, we don't know. The models are versionalized. Specifically, if you built any model in the AutoML, you can extract any version that you've created by just using the REST API and extracting it out. Specifically, with respect to your code recipes, at the current moment now, but that is a feature that we're working on as well, to go ahead and save that version of the recipe that's run with respect to your model that's been trained.
Awesome. John, thanks so much for a great presentation and for handling all the questions. And thanks everyone for attending and asking great questions. Hope you enjoyed day 2 of TWiMLCon, and we will see